For our second lecture, I want to introduce the notion of a digraph and its connections to the concepts of matrices and vectors as we've developed them so far. So what is a digraph? So a digraph is shorthand for the notion of a directed graph. And a directed graph is a very simple object. It is a collection of nodes and arrows. So a typical digraph might look something like this. So the thing to pay attention to here is we are looking at a figure where we have a bunch of like dots here, which are labeled as V's with subscripts. And then we have a bunch of arrows pointing in between these dots. These dots are called nodes and the arrows are called arrows. And so for example, in this figure, we are looking at a directed graph or a digraph with 6 nodes. So if we count the nodes, there are 1, 2, 3, 4, 5, 6. And 7 arrows. So if we count the arrows, we see there's 1, 2, 3, 4, 5, 6, 7. And why are digraphs interesting and worth talking about? Well, in applications, digraphs are used to describe relationships between objects. So if you're thinking about something that you care about in the world, and that thing can be explained, at least modeled, by things that have relationships with one another, a digraph might be a useful tool to study the thing you care about. So here's a sort of typical kind of example. So we can imagine like our financial network as just a giant digraph. And here the idea is that each node in this digraph represents some financial institution. So here I have the logos for 3 famous banks. And the arrows pointing between these nodes might represent transactions between these banks. So this first arrow here, T1, might represent a transaction where Wells Fargo sends Chase Bank some money. And then T2 might be another transaction where Chase sends Wells Fargo some money. And these other transactions represent other banks sending other banks money. So here the idea is that we're modeling transactions between financial institutions. And of course, this is a very simplified model. If we wanted to account for all transactions in, maybe all banks in the United States, we'd have a much more complicated figure. Search engines can be modeled this way. So search engines use hyperlink data to model the internet. Here I have the logos of 4 famous websites. And then I have arrows pointing between all these various websites. Maybe in this model, the idea is that each arrow in this directed graph represents a link from one website to another. So in this digraph, maybe Wikipedia has a link labeled L1 from Wikipedia to Amazon. Maybe L2 is another link from Wikipedia to Amazon. Maybe on Amazon, there's a link to Wikipedia. Maybe there's also a link to YouTube, so on and so forth. So again, here I just have a small example to illustrate a much larger model. So here the idea is that we're modeling hyperlinks between web pages. And social networks could be modeled this way if you wanted to. Here I have a figure, I guess Facebook released this. I don't remember the year, but I have the reference down here. I think it's from 2010, but it might actually be later. And so what you're looking at is a directed graph they constructed to model their social network. So the idea is that there's probably billions of arrows here representing connections between accounts. Okay, so